Writing a function rule. The objective is to write a function rule given a table or real-world solution. So that just means a word problem. Write a function rule for each table. Okay, step one, you're going to put y equals. I'm going to turn fx, they're going to give you fx sometimes, or make it y. So I'm going to say y equals. And that's how it always will start off. Step two, you're going to tell me what you add or subtract to get from the first number to the second number on the y side. So 5 plus what will get me 6 plus 1. Doesn't work all the time. 6 plus 1 equals 7, and 7 plus 1 equals 8. So this number will be times x. So I'm going to say 1x. Then, step 3. What do I need to add? What do I need to add or subtract? Okay, so I'm going to take this box right here and plug this number into it. So I'm going to go 1 times 1 equals 5. Is that a true statement? 1 times 1 is 1 equals 5. No, it doesn't. So what do I have to add to get to 5? So it will be 1 plus 4. So 1 plus 4. Let's see if it works on all of these. So to check it out, I'm going to go 1 times 2, which is 2, plus 4 equals 6. How about this one? 3 times 1 is 3 plus 4 equals 7. So here is your answer. Y equals 1x plus 4. If you just want to say y equals x plus 4, you can. This one's a little different. There really isn't a set this way to do it. So we're going to have to look at y equals. We're going to do this. Let's look at it. 1 plus what will get me 1? 1 plus 0. Well, does that work with the same here? 3 plus 0 equals 9? No. So it can't be plus 0. So I'm making x something. You always have an x. Y equals x, or 3x, or 4x, but it has to have an x in there. So this would be like plus 8, and this would be plus... So notice I have 8, 27, and 45. If they don't have the same number throughout the whole thing, you can't multiply it to the x. So we leave it out. And then, so, something times x, because plus 0 is not going to work. 1 times, since it's not anything over on the side, it can't be 1x or 8x, 8 times x, or whatever. So I'm going to say, what if I square them? X squared. So if I square 1, 1 squared equals 1, 3 squared equals 2. 3 squared equals 9, 6 squared equals 36. So I can square it. There's your answer. C. What did I do? Okay, step 1, we have y equals. So we have already our y equals. And then I'm going to go from step 2, how much am I adding or subtracting by? So I'm adding -1 plus something gets me 0. That's plus 1. 0 to 1 is adding 1. 1 to 2 is adding 1. Well, they all have the same, so it's going to be 1x. 1x, so means a is out of it. So here's 1x and 1x. Now I have to try out the rest of it. I have 1x, so 1 times x is 1. How do I get from 1 to -2 then? 1 to -1. Well, that's time it's a smaller number, so I'm going to subtract something. 1 minus what is going to get me -1? 1 minus 2. Very good. So 2 minus 2 equals 0. 3 minus 2 equals 1. 4 minus 2 equals 2. Yep, that works. So which one has a subtracting 2 to it? That would be B. So there's your answer. Okay. On your homework, in your book, you have a picture of this model. So it's not really on the left-hand side of your book. On your notes, but in your book, it's on the left-hand side. It's on page 271 if you want to see it. Okay, the exhibit at the left, okay, is a scale model of a desktop computer. It is about 20 times the size of a normal size desktop computer. Okay? So we're going to write a function for it. So it is a real computer. You find it in the Museum of Science in Boston, Massachusetts. So they have a old-fashioned computer, 2000, and you can walk on top of it. Little kids mostly do it. So we're going to write it, and like I said, we're going to do y equals, and we have an x. Okay, so we have, it is about 20 times the size. So these two should give away what you're going to do. It's 20 times the normal size. So it would be y equals 20 times x, and that's all you're doing. And that's it. Okay, let's try B. A carpenter buys finishing nails by the pound. Each pound of nails cost $1.19. Okay, again, I'm going to do y equals x. The x equals like your pounds, LB. This is your size. Okay, and this is your cost. The full amount of cost. So, how much is it per pound? It says each pound. So that's telling me it's a multiplication problem. So it's going to be $1.19 per pound. Okay, I'm going to add something to it. How much will it cost if I buy 12 pounds? What I'm going to do is I'm going to use this equation and plug it in. So it would be y equals 119 times 12.
Miss Frederick, Miss, yeah, I'm doing it again. Miss Carson, you're in here.
Cost me $14.28. Another word problem. Suppose you borrow money from a relative to buy a lawnmower. That costs $245. You charge $18 to mow a lawn. Write a rule to describe your profit. I'm going to just call this y. We've been doing y's. As a function of the number of lawns mowed. So I'm going to do y equals, and so how much per lawn do I have? Well, it's $18. And then I borrowed money. Is that a good thing or a bad thing? It's borrowing's taking money away, so it's minus $245. And there's your function. Okay. Suppose you buy a word processing software package for $199. Again, you had to pay something. You charge $15 per hour. So again, y equals x. I'm at x right here. So I'm going to charge $15 per hour. So it's $15 per hour. That's how much money I'm making. And then I'm subtracting how much I bought, and that is your answer for that. Goodbye.